Okay, I was thinking of starting up again and taking the next part of the lectures. Let's see. It looks like we have some people here, so I think I will just start now. Okay. One thing first. We checked with the system administrator group, and it seems that the S-cancel minus U, your username, should actually be working again. So you should be able to just use that and kill all your jobs. And that is significantly easier then. So S-cancel minus U and the username kills all your jobs. Okay, first I would like to start out with showing how you can log into the HPC2N system and testing if your user accounts are working and things like this. So first, if you have not already installed something like ThinLink, then I would like you to go and do that now. And I can see if I can find the website where you can do that. But it is linked from the important information page. Just one moment. I will share my screen. So there is this important information page that you got the link to from the email I sent out. And in this, there is guides for the for how to use the various connection systems, how like SSH or whatever. But if you don't have anything installed that you want to use, then you should use ThinLink. And particularly for this course, since Pedro is going to have some application examples, which will be made much easier if you have a graphical interface that is running directly instead of having to use SSH minus Y. It should also run faster, ThinLink, than an SSH with the graphical interface. So here the thin is the link to our documentation about using ThinLink. And I will copy this link and then I will open it. And you can see here, it first says download the ThinLink client from this page. And then if you go to this link, then you have different options for what to download here. And what you should download is one of the ThinLink clients, not the servers. So remember to download the 64-bit one if you have that, or the 32-bit one in case you should have that. And there is on this HPC2N page a description of how you install it, but it's quite simple. As soon as it has downloaded and installed, then you start up the ThinLink client. And the name that you should connect to is this one. Kebnekaise -tl.hpc2n.umeå.se. And then it will, in this screen here, you will put in that on the server. And then you will put in your username. And then you should also put in your password. If you don't, it will ask for it, but there is something that does not get set up correctly, so it will fail, which means you should put the password here. And then you should go to options and security, and check that the authentication method is set to password and not to SSH keys or something else. After that, you should also, under options and screen, you should uncheck full screen mode. And that is quite important to do, because otherwise it will take up more space than at least a small screen like a laptop. And then some of the commands and some of the tabs and things will be outside of the screen, which makes it kind of difficult to operate. And when you put in your HPC2N password, you should click connect. It will then ask, complain about the service host key not being in the registry, and you should just click continue. And this comment here is someone from the system administrator group who has wrote a comment to ourselves here. I don't know why, but I agree with them. We should put the valid key somewhere. Anyway, it takes a little while for it to start the first time, maybe up to a couple of minutes. But then the ThinLink desktop will open and it's running something called Mate, which is similar to GNOME, if you know that. But in any case, it's simply a desktop. And you can then access all files on HPC2N there. What you cannot access easily from there is the files you have on your own computer, of course. Those you need to transfer first. But we will explain more about that if you need it. And otherwise, there are documentations on how to do that also on the HPC2N website. What I will do now is that I will actually start this ThinLink client on my home computer.
Excuse me, do we have time for a question?
Yes, certainly.
Is there any downside of using the ThinLink rather than connecting by like the PuTTY or something like that?
No.
Okay,
the only thing is that the ThinLink client has a different login node than PuTTY would have. If you connect with PuTTY, you just use Kebnekaise.hpc2n.umu.se without the -tl.
Okay.
And as long as you are not using any graphical interfaces, then PuTTY is just as easy.
Okay.
Otherwise, you would have to install
Xwing
or something.
Terminal on the ThinLink as well?
Yes.
Okay. So there's really then I don't really see any reason of using the PuTTY for me as a casual user.
No, I mean, ThinLink is slightly heavier on your system.
Okay.
And it also takes up the entire screen. So if you just need a small terminal window and otherwise want to access other things on your own computer, then maybe it's easier to just have a small terminal window. But in every other case, I would say running ThinLink is probably easiest, because it sets up an X11 server as well, so you can run graphical interfaces and all that. And you can mostly just point and click in that, except for when you open the terminal. So
perfect, thank you. I also tried connecting with the WinSCP for file transfers, but didn't manage to do that. Is that because I used the wrong server? Is there another server? You mentioned something about
that
the
should
server
work.
being different. Like
the server is different if you are doing file transfer. Then you should not use the -tl.
Okay.
For file transfers, you should just write the Kebnekaise.hpc2n.umu.se, because the Kebnekaise -tl server will not accept any other connections than through ThinLink.
Okay.
So that's why.
Thank you.
So now I have put in my password here, and I can just briefly show you how it looks here under options. So you can see this here on the screen. I will check that it has unclicked this full screen mode. It is not marked, so that's good. And resize remote session to local window is as it should be. Then I can go to security and check, yes, I authenticate with password, so that is fine. Okay. And this here, the end existing session, that can be used in case when you try to reconnect to the system and it's not working, then it might have entered a bad state somehow. And you can then mark this end existing session and connect to it, and then it will refresh it and start up a new connection. Otherwise, it is possible to disconnect from the ThinLink session and leave things running in there. And then you could end it with this if you had done that. But now I'm going to start it up. Okay. See, it goes fairly fast now because this is not the first time I connect, and that means that it has already done all the configuration stuff. And it looks like a standard desktop, as you can see here. And here you have these things here. You can, for instance, log out, shows here, and places. So you can open just like you do on a Windows system, for instance. And what is important to pay attention to here is that if you go to Applications and HPC2N, then here are the disconnect and the logout. The disconnect will just disconnect you from it, whereas the logout will log out completely of the session. So, and there are a few things that can be run directly here. You can start MATLAB and RStudio. There is a Firefox browser. And here down on the system tools is what is important. You will need, which is run a terminal. And that is how you would access most stuff. And the one you should run is the mate terminal or meta terminal, maybe. You can take things like this, click on it and pull it and put it here in your bar here. Then you will have a direct link to it instead. So let's open one of these. And then I would like to go to, let's see, I have put all the materials here in one place, also where you can get it from. Let's see, it was in intro course, I think. Yes, on this. So I will open another one here, and then I will show you. I just need to check what it was called. Let's see. Probably see it there. This. So what I would like you all to do is download and install the ThinLink. And then when you have done that, try and connect to this system here. And then you can use this command when you have logged in, passwd, and that when you run that, it will change your password from the temporary password you have gotten to something that is easier to remember. So type passwd, press enter, then it will ask for the temporary password you were given, and you will type that in, press enter, and then you will type in a password that you would like to change to. and press enter, and then repeat this password and press enter, then it will be changed. And you should do that because the temporary password that gets created is very not easy to remember. And let's see, we want also to go and change our set up our own space for running things on the system here. So you can go to this directory here, proj backup SNIC 2021 -22 -514. That is this directory for the storage for this compute project. And you can see here, this is where we want to create a directory for ourselves. So you can call it what you want to, but I would suggest naming it the same as your username. It makes things easier. So I now create a directory for me here. You can see it's here. So let's go into it. There's nothing here. And then the easiest way to get the hands-ons this time is probably to copy it from the place I have put it, because then you don't have to transfer the files to HPC2N right now. So the easiest thing is probably to copy it. And you do that by saying copy. And then from this place here, let's see, actually I need to copy it from my place. So it's home/b/ store intro course. Nope. See.
So, Birgitte,
Yes.
there is one question on the chat.
Yes. I will look at it. I will just make this bigger so that it's easy to see for everyone. Like this. Okay.
Maybe
And
you
then
can
this dot.
maybe you can
See.
copy and paste this long command on the chat as well.
I will. I just want to see.
Birgitte?
No, it's not. It's not optional. It's not. It's optional. Yes, you can use putty instead. That is fine.
Oh, thank you. Thank you very much.
So you are so you log in using either ThinLink or putty or whichever client you wish to use to connect with. And when you have done that, if you are using something not ThinLink, then you should type this command. Just one moment. Why is it ignoring me? Okay, but I can take my own machine for that. Let's do that like this. Okay. If you are using something else but ThinLink, then you will connect with a command like this. SSH your username at Kebnekaise.hpc2n.umu.se. If you have a X11 server for graphical interfaces, then you would do like this: SSH -Y your username at Kebnekaise.hpc2n.umu.se. And when you have connected to either Kebnekaise login node or the Kebnekaise ThinLink login node, then you should go to the area called no backup SNIC 2021 -22 -514, this one, like I did up here. And then you should create a directory for yourself with mkdir, your username. And then you should change to that username, which I neglected to do. Or did I do it? I seem to have done so. I just don't see where. Okay. So go into this directory that you just created. And then when you have done that, you should copy this file, home, B, and all of this here. I think I have some issue with this not responding. Anyway, I will just leave this up for you to see. You should copy this into your home directory or into the probably the directory you just created on the project storage, because that will contain all the slides, and it will also, more importantly, contain all the hands-ons. So let's do this. This is the introduction to usage of the HPC2N system. And I will talk briefly more about the projects, and then using the system, a little bit about the file system, and then the module system, which is what we use to access the software here at HPC2N. Then very briefly about how to compile and link with libraries, and then the batch system. And after that, there will be a break. And when we come back, we will look at simple examples. And after that, Pedro will show some more advanced examples and some application examples. So first here, the projects. There are compute projects and storage projects. And the one you have is a compute project, which I have applied for. So I'm the PI of this compute project. And it is a small project with less than or equal 5,000 core hours per month. And those are the ones that anyone PhD student or above can apply for. Medium projects are bigger, and there you need to be an assistant professor to apply. And the large ones only have rounds twice a year. And that is for so-called senior researchers in Swedish academia to apply for. Anyone can be a member of all of these projects. So when you apply for a compute project, you can choose to apply for the default storage. You just click, yes, I want that. And then you get one of those, which is a small storage, is 500 gigabytes. And if you go to this link here on SNIC, then they give more information about all these compute projects. If the 500 gigabyte is not enough for you and the other project members, which is often will not be, then you need to apply for a storage project, or rather the PI will have to do that. You can apply for a small one, which is usually what you will do if you have a small compute project. And then you will get up to 2 terabytes of space for you and your project members. There is also medium projects for storage, and those are the larger than this, up to, I think, 5 terabytes. And they have 5 to 10 terabytes, and they have monthly rounds, just like the medium compute projects. And then there are large storage projects, which are more than that. And those also are only twice a year, like the large compute projects. And information about that can also be found on SNIC's website on the snic.se allocations and /storage. As I mentioned earlier, you have 25 gigabytes in your home directory. And then there is the default storage of 500 gigabytes, and then more the storage project. This shows how it looks on the super page. I have here asked for the resource Kebnekaise, and then I am being offered to have the default storage, and it looks like this. And then I can either decline it or I can accept it. And if I'm going to ask for a storage project itself, then I should decline it. If I feel that 500 gigabyte is enough, I will accept the default storage. And now I have accepted it. I can pick the directory name or the directory name type. And what I would usually just say here, give me the default one. And then I will just get that, which will just be here, accept a new default directory name, which will be the same as the name of the compute project. And that makes things easier, I think. But otherwise, you can name it something, especially if you have, and if you're applying for a project to continue another project, then maybe you don't want to change the directory of your storage project. You probably would want to continue having the same name. So in that case, you would put in a name here in directory name. When you have applied through Super, or when the PI has applied, the project will be reviewed. And small projects are reviewed every week, and the small ones are basically always approved. Then the PI should link together compute and storage projects if you have applied for both, and that is done from the storage project. And the good thing about this is that all the members of the compute project automatically becomes members of the storage project, so the PI does not need to add them twice. And this is how that looks. So you can search for compute project to link, and then you can also show storage allocations and other things. So there is some information about that. And here, if you have more of them, you can search for it. And here I'm being told I have this one. It was last year. And then I would simply click link. This is how it looks. This is the storage project. And this is linking to the compute project. So, and this is how it looks after I have linked them. And then you can see all the project members, which was then the same as for the compute project. Okay. We already have a compute project here. So for now, let's look at using the systems instead. And this is when you're using PuTTY or any other SSH client except for the thin link. You use the Kebnekaise.hpc2n.umu.se. So you would connect to that, you would transfer your files and data if you had any. Then you would load modules if needed. And then you had either you have your own code, you would compile it, maybe you want to install some software, or you will run pre-installed software. And then you would create a batch script and submit a batch script and possibly then download data results. So this is how it would look when you were going through and doing your jobs on the system. And here is some information about how to connect with ThinLink. And this is basically what I just told you before what I was going to show you when it decided to go down. Some So if you want to transfer some files and data, if you're on a Linux system, then we suggest using SCP. You can also use SFTP, but it has to be secured file transfer. If you're using Windows, you would have to download a client. You can use a WinSCP, again connect to this. And you can use FileZilla with SFTP or any number of other clients that you may have. And we have some documentation about how to transfer files. If you are using a Mac system, you can either do as for Linux in the terminal and use SFTP or SCP, or you can download a client like CyberDuck or Fetch or some other one. And there is also more information on the page there. So how do you edit your files? Well, Pedro already talked a little bit about it. And you have various editors. You have VI, Vim, Nano, Emacs, and things like this. And the easiest one to use is probably either Nano or Emacs if you haven't used any Linux editors before. If you're running in a terminal, I would suggest use Nano. And if you are running in the ThinLink, you could open an Emacs also. And that can also be run from a terminal, but it's easier to run that graphically. So if you're just running in a terminal, use Nano. So just Nano the name of the file, and it will create the file if it does not already exist. And then you save and exit it with Control X, and it will ask to save, yes or no, when you exit it. So the HPC2N file system here. There is an overview of it on the web, but otherwise here is a small table that shows it briefly. There are the project storage, and it is recommended to run for batch jobs. And you could run them in your home directory, but it's not recommended, mainly because of space. There's only the 25 gigabytes there, remember. And you can run it in Scratch, but again, then you need to copy stuff. The project storage and the Scratch are not backed up, but the home directory is. So if it's something that cannot easily be recreated, it should be in your home directory. If it can be created again reasonably easily, it can be in your project storage. They are all accessible by the batch system, but the Scratch space is only accessible while you're on a specific node. And the performance of these file systems should be high in both the project storage and home, since it's on the same file system. The default readability for the project storage is your entire group, and for the others, it's only you. Permission management is done with the change mod, change group, and also with ACLs. And in Scratch, it's not applicable because batch jobs, you cannot change anything when you're on the node there. So the project storage, remember, this is the storage your group gets from a storage project. $home is short for your home directory. It's also called /home/ first letter of your username / your username. And the Scratch space is per node. So run in the storage project if you have one. And you can, as I said before, you have either picked a name or you get the default name. And this is where the storage project is located. And I showed you that briefly on the ThinLink. And remember that it is shared between all users of the project. You must create a subdirectory for your things, otherwise everything gets messed up. So what is the module system? The module system is what HPC2N and actually most of the HPC centers in Sweden are using to access software. They are used to set up the environment paths for the executables, libraries, etc., for particular sets of software packages. And it means that you can easily load everything for a specific type of software and then remove it again, even if there are different versions of it. For instance, if you are loading libraries and compilers of a specific version of either Intel or GCC or something like that, and they will all be available, but you load them one at a time. They are installed hierarchically. That means that some of these modules will only be available after you have loaded a specific compiler and or MPI version. So here are some of the useful commands. If you want to see which modules exist, all of them, it will just you can use module spider or short ML spider. That will list a very, very long list of all existing modules, but not the versions of them. If you do module avail or ML AV for short, then you will get the modules that are available depending on what is currently loaded, which can change. And then to see what do you have loaded, that is the module list or ML. So let's take an example. If you want to load what we call a compiler toolchain, that is a compiler and various libraries, for instance, GCC, you would load module load, and it's called fos/version or ml fos/version. And we will look at later how you see which versions are available. You can do it, for instance, if you say ML Spider and then the name of a piece of software, for instance, ML Spider GROMACS, then it will list all the available versions of GROMACS. And if you then say ML Spider GROMACS / and a version name of those that it listed, it will tell you how to load this and which prerequisites that has to be loaded first. To remove the module, then you use module onload, the name of the module, or ML minus the name of the module. If you're doing ML show name of module or module show name of module, it will give you more information. And with ML purge, you can unload all the modules at the same time, except for a few that are called sticky modules. And those are modules that contain environmental variables for SNIC and other things. So those you don't want to remove. This is a non-updated list of current available toolchains. The thing is that they change pretty regularly, so you will have to check that with MLAV. But you can see there are GCC, that would just be GCC itself. If you take GCC CUDA, it will be GCC and the CUDA compilers. The FOSS is the GCC compilers, OpenMPI, OpenBLAS and LAPACK, fast Fourier transformations, and ScalarPack. And you would also have a FOSS CUDA somewhere, which is not listed here, but that is the same one, but as this, but with CUDA as well. And as you can see, there are many different combinations. For instance, just Intel compilers, or Intel compilers and CUDA, and all the Intel libraries also with Intel MKL and CUDA and so on. So how would I link with a library? Well, if you are using Intel MKL, the easiest thing is probably to use this URL here, where Intel will ask you some questions in a small drop-down menu, and then it tells you what is the command for linking with. But you can actually now also use this build env, but that you should always use if you're using GCC. And to access this, you are loading a compiler toolchain, and after that you do load build env, And if you say ml show built-in, it will give you a long list of all the variables that are now accessible. And that tells you linking info. And it is highly recommended to use the environmental variable, which you preface with a $sign for linking. Remember, you have to load the built-in module in order to do that. And I will show that when the file system is again available. So let's look at the batch system. If you have large or long jobs, parallel jobs, then you have to run them through the batch system. If it's just something short as a test that runs a few seconds, less than a minute, and not use a whole lot of resources, yes, then you can run it on the login node just to see that it will run. Or you can just start it up and run and then kill it immediately if it's long. But otherwise, you should run through the batch system. Slurm is an open source job scheduler, and it provides 3 key functions. It keeps track of the available system resources, enforces local system resource usage and job scheduling policies, and it also manages a job queue where it distributes work across the resources according to policies. So in order to run a batch job, you must create and submit a Slurm submit file. And this can also be called a batch submit file, batch script, or job script. And it will, if you Google it on the internet, you will find out that people call it any one of these things. We have some guides and documentation on our HPC2N website under support. So you can see the URL here. So how is this accounted? Well, it matters what type of node you are running on. And with accounted, we mean to the project allocation that you have. It's not that it costs money, it's just time from that project. So if you're asking for some number of cores that is less than 28, remember there are 28 cores on one node on the Broadwell nodes and the Skylake nodes, then you get that number of cores exactly. If you're asking for 28 cores, then you get that also. But then when you go to above 28 cores, that is what matters, because in this case, it will allocate it in whole nodes, which means that you will also be accounted for that. So say you ask for 29 cores, it will actually allocate 2 full nodes despite that. And you definitely don't want that, because then you get accounted for 56 core hours, even though you're only using 29. So unless you really, really need slightly more than one node, then try to keep it close to whole nodes or less than one node, unless it's necessary, of course. And you can also ask for full nodes, in which case it's again easy and you get accounted for full nodes. For the large memory, it's exactly the same thing, except that here there are 72 cores. So that is the number instead. So what about the GPU nodes? That is a special case. And the reason for this is twofold. For the first, there are also 14 cores on this GPU nodes or this socket. And you can allocate one socket, that is 1/2 node. And that is the smallest unit that you can allocate. And these cores, the CPU nodes on the GPU node, they cannot be used by anyone else while you are running on the GPU engines. And because of this, those cores will also go into what you are accounted for. So that is the 14 cores I have over here. And then we have decided that the 20 core hours is suitable for what usage of one GPU should be accounted for. So that is 14 of the CPUs and 20 for the GPU, which is 34 core hours. And of course, you can try and write something where you actually use the CPUs at the same time, but otherwise, this is just because no one else can use them. And if you're using one of the nodes that has 2 GPUs, then you can also ask for 2, and then you get accounted for 68 core hours. Sorry, which is double of for one of them. It's the same thing for the V100s as it is for the K80s. Some of the Broadwell nodes have 4 K80s. So in that case, you can also be allocated for that. If you're asking for this, you can ask for up to 4 K80s. You can only ask for 2 V100s because there are only nodes with 2 of them on. So what are some useful commands for using the batch system? Pedro already mentioned several of these, but to submit the job, you use the sbatch and the name of your job script. And just to repeat, job scripts can be named whatever you want to, but it is common to name them as something.sh or something.sbatch or something like this. But it's not necessary. You can name them exactly what you want to, as long as you can easily yourself find out what is your job script. To get a list of all the jobs that are running, you do sq-u, your username. And you could also run things directly on from, give all the commands to the batch system on the command line, and then you would use srun and then put in all these commands that you have in the job script. But I would recommend doing a job script because then you can easier see what it was you did and you can easier redo it next time you're running it. To check on a specific job, you would do scontrol show job and the job ID. And the job ID, you got that when you submitted it, or you can see them with the sq-u, your username. To delete a specific job, do scancel and the job ID. And we also now found out you can do scancel -u and your username to kill all your jobs. And you can use the commands sacct to get more detailed info about jobs. And you can, in this case here, I am just giving an example of how to see a list of how much memory is used and things like this. The thing is that the output of this command will be very, very wide. And it is several screenfuls wide. So you should pipe it and less -S. That will make it scrollable. So you can use left and right arrows to scroll on the terminal. And of course, you can always use man for the sbatch, srun, and whatever to get more information for the manuals. So the output from a batch job as default will end up in a file that's called slurm-jobid.out. And you can look at it with commands like vi, nano, or emacs for the editors, or you can just use cat or less to see what the output is. And if you want the output and the arrow file split up, you could, for instance, use flags like this in the submit script. So the hashtag sbatch, which is telling the batch system this is a command to you, --error equals job.%J.err. Of course, you do not need to name the files this. This is just to make it easy. This environmental variable here, %J, it contains the job ID. And the advantage of adding that to your output files is, of course, that you get a new one for each job you run. Whereas if you call it my error file, then it will be overwritten every time you run it. And that is probably not what you want. And you can do the same thing for output files. But of course, this part and this part, you can just call what you want. Then how do you run on the large memory nodes or the fat nodes? If you have access to that, which we don't in this project, but if you had applied for it, you would use the hashtag sbatch -p large mem. And it's also possible to say that you want to run only on the Broadwells or only on the Skylake CPUs. And that can be important if you want to make sure that the performance is the same from time to time, that it doesn't just pick something randomly. It will probably not be important if you are running most types of software that is already installed, but it could be important if you have your own code where performance matters and where especially that it matters that it can be replicated next time, the same performance. And then you would constrain it with a -- constraint equals either Broadwell or Skylake. And to use the GPU nodes, you would use the hashtag sbatch --gres equals GPU : and then you put the type of the card, which is either K80 or V100, $x, where X is 1, 2, or 4 if it's K80s, or 1 or 2 if it's V100s. And there's more information here on this guide on how to use Kebnekaise. And that also explains how to do some other constraints. So let's take a simple example of how to run a serial job on the Kebnekaise through the batch system. And in this case, I am loading the compiler toolchain called FOSS. So first we have this thing that looks like an incantation. It tells the batch system that I want to run in the bash shell. And the reason for this is that it's the only shell that is completely compatible with the batch system. There are several shells that can be used. Bash and C shell are probably the most popular ones, and it is not really relevant in this case. Just remember to always put this here to make sure you don't get weird errors. Then you need to tell the batch system which project you are running in. And in this case, we are running in this one, which is the one we have for this course. And after the course, you should of course change it to your only one. Your own one. But note that this one will be available for several more weeks until the 1st of October, most likely. So you can run some tests on these examples later if you want to. And since this is a serial job, I'm just asking for one core here. And I'm saying I would like to run for at most 5 minutes. So I'm asking for 5 minutes here. Note one thing, which is that it will only account you for the time that it actually runs. So if it ends up running for only 3 minutes, that is what you get accounted for. But you should be aware that if you're asking for too short time, then the job will not finish because it will break when that time has passed. If you're asking for too long time, then the job will sit in the queue for much longer than needed. So that is also not a good idea. So try to be reasonably close and in your estimate. You can test it first. So it's always a good idea to purge modules before you load new ones, if you have anything that carries over from the terminal. And then you load the modules that you are needed here. In this case, I am loading FOSS, and I'm loading the version 2019B. And then I'm running my serial job, just like I would on the command line with /my serial program, or whatever the name is. And then I submit it with sbatch job script. And I will also show how to run an MPI program. This is just a small MPI program I wrote that I can use here. And as you can see, it's very much the same as it would be for running a serial job, with the exception that you ask for more cores. And here I also are showing something that is just, you can do it, say you want it exclusive. In that case, no one else can run on this node, but I have commented it out. So this is just to show a command you could use. And I'm also running it in a reservation to see how that will go. And for this course, only during the course, we have 2 reservations, and I will talk more about that in a moment. But the important thing to look at here is ask for more cores, load your modules, and then you use srun in front of the command to start your program to tell it to run on all the cores. You can also say srun -n some number of cores, and then your program, if you only want to run on some of the cores. And now our program has run, and let's see what it looks like in the output file. See, so I'm using cat. And then it looks like this. Each of the processors said the hello world and is telling you which one it is. And as you can see, it's random. And it would be different if you ran it again, because you cannot control which one of the cores that reports first in this way. There are many other things you can do, and I will show a few small examples here. So what if you want to start several serial jumps in the same submit file? You might want to do that because then it doesn't have to sit in the queue for each one of them. And what matters here is that if you are all running them at the same time, you need to ask for enough cores for all of them. And you need to ask for enough time that even the slowest one of them has time to finish. So I have 5 batch jobs. I start each one of them. And then I have ampersand at the end after to telling it that there will be one more. And also I have the command wait, which is important because otherwise the job will end when the first one of them ends, and you don't want that. You want to wait until they all have ended. Let's say you want to start a lot of parallel jobs sequentially. And again, ask for enough cores, and also make sure you have time for all jobs to complete. In this case, I want 14 tasks with 2 cores per task, and I want to put the output to some file. Of course, note that if your job already creates output in a file, you don't want to do this. I mean, many programs will already throw output themselves, but in this case, I'm throwing it to a file that's called my output 1, my output 2, my output 3. And this one tells it to put both errors and outputs to the same file. It's a bash command. And after that, I'm taking this output and I'm copying it to a specific directory. This is just to show some examples of what you can do in a submit script. And I am running them one at a time, so there's not an ampersand here at the end. So, and it doesn't have to wait because it's taking them one at a time. And that also means that you only need enough cores for the one that needs most cores, because they're not running simultaneously. And you need enough time for all of them to complete one at a time, if you're running it this way. You could also run them simultaneously, and the difference is then you put the ampersand at the end, and you have a wait at the end, and now you need enough cores that all of them can run. And you also need enough time for the longest of the jobs to end. And in this case, this is just running the nodes, or run the nodes here. I'm not copying anything. And I'm using this command, which is CPU bind to cores, to make sure they are not moving around on the course during it, which they can otherwise do when they're running, and it matters when they're running simultaneously. We want them to stay on the course that they are running on. So what about a small GPU job? That is also very easy to run here. You are telling it simply how many GPU cards you have needed, like this. Crap. And you are loading a toolchain that has CUDA, for instance, and then you are running this small GPU job. So, important information all put on one page. The course project is this one. To use it in a batch job, add it to the batch script. Hashtag sbatch -a SNIC 2021 -22 -540. 2 nodes has been reserved for this course, so we can run the smaller example without having to wait for too long. One is a regular CPU node, the other is a GPU node. They are only valid during the course. The CPU reservations is intro minus HPC, and the GPU reservation is intro minus HPC minus GPU. And you can add them with the hashtag sbatch -. This should be 2 minuses, but apparently they have floated together somehow. Reservation equals, and then the name of the reservation. They are, I think, put in some of the examples where you can see it. They will have been commented out in the examples where I've added it, so that you don't accidentally put it there later. You should also notice that since it is only one node, it means that if someone is running a long job on it, it may take longer still for everyone to get to run on it because it's only 28 cores. But if you are all running short jobs or few cores jobs, then it should go faster to use the reservations. If it ends up sitting in queue for a long time, you can try removing the command to use the reservation from your job and see if it goes through faster. But in most cases, it will go faster with the reservation. Then also note this thing about the storage project that's linked to the compute project. It's this one, and you find it in this location. When the file system works, go there, create your own directory, copy the files there. If you have any question, you can ask me or Pedro or support or now or later, or you can just write it into the Q&A document, and then we will answer questions there. We prefer if you write things to the Q&A document during the lectures, because then it's easier to see it and not miss it, because if everything scrolls by in the chat, maybe we don't notice it. And this way you can also go back and look at it later, because the Q&A document will stay there. So this is the link to documentation on the websites, and support questions can either be put through the super page, or you can send them directly to support@hpc2n.umeå.se. Okay. Okay, I think it is time to get started again. It's 1 o'clock. I have just talked to the system administration personnel, and it looks like the file system is up and working again. And I have just made some small tests, and it seems to be running. So it should be fine, I think, which is good.
So one thing, thin link is still not working well.
It's working for me.
Yeah,
I just
it's working
tested
for
it.
me also. Yeah, it is okay for me also.
Yeah, try
Okay.
restart it, Pedro.
Okay,
I think
yes.
that might, yeah. So I will try and share my screen again, and then we should continue what we started before my lecture. Okay, so this is my ThinLink session, and it's working again, it looks like. So let's try and do some things while it's working. So if people manage to get some sort of SSH client working, so either, as I repeat, either log in with the SSH client you are using, like WinSCP or whatever the name is for it, the Windows. There is various SSH clients. You can use PuTTY, you can use ThinLink, you can use whatever you would like to use. If you're logging in with ThinLink, you log in to Kebnekaise-tl.hpc2n.umu.se. If you're using any other SSH client, you log in to Kebnekaise.hpc2n.umu.se. In both cases, you use the username for HPC2N, not for super. They are separate. You will have a password, or rather, there is a link in the email you got sent about your account creation that directs you to the HPC2N password restore service, which is where you create the very first password. And you do that by logging in with your super credentials on that page. So when you get the HPC2N password, you can use that to log in to HPC2N, either with ThinLink or some other SSH client. When you have logged in, you can change the password with the command passwd. Put in the temporary password you got from the restore service, press enter, and then write some password that you want to use. Press enter, repeat the password, press enter, and it has been changed. When you have done, yes?
Just one question. Can you access the no backup and the like the project folder through the file explorer as well, or is it only through the terminal?
You should be able to access it through the file explorer. Let's see. Why is it not doing things? It goes to Windows Network. Let's see what it does here. Well, what you can do that should work, well, file system should work. Yes, click on that one that says file system. And then here,
I think if they do a soft link, then they could see a folder, right? In the home
yes,
directory.
they can do that, but they don't even need to do that. But yes, it makes it easier. But if you are just here, see, this one you will always have. That's called your home. So click on that one, click file system, and proj, and no backup. And then the one that you have, which I of course cannot remember. And which now got themselves hidden somewhere. There. This one, SNIC 2021 22 514. this one. So yes, you can access it here and then here. But I find it easier to use the terminal windows for this. Especially when you have the damn zoom bar up here that blocks me all the time. Okay. Okay, but as Pedro said, we can also go and make a soft link for it. So let's do that. So open a terminal window. You do that with click Applications, System Tools, Mate Terminal. Or if you are using just a terminal window from some SSH client, you have your terminal window. And then you want to make a soft link from your home directory to the place where the storage directory is. So you would do ln -s and then
Birgitte,
yes.
would you mind increasing the size of the font?
Oh, sorry, of course. Is this better or should it be bigger?
A little bit bigger.
Like this?
Yes, for me it works. Thank you. Yes, yes. Thank you.
Okay. So n-s and then this long thing here /home / sorry, this should be your own one, of course. It's called /project /no backup /SNIC 2021 22 514, and then your username here, or whatever you call the directory there, and then maybe course storage or whatever you want to call it. So type in this thing here. I can put it on the chat as well. So you make a soft link to this directory and then call it whatever you want to call it, so it makes it easier for you to remember that this is the place to go to. I would put BBRYDSOE because that's my username here. So I can try do this. Then I can do this to go to it. And I can show you that this is the same location as the other one here. But remember, you need to create this directory first. So go to this place, cd to this, and then change to it. I will just copy this file.
There is one question on the chat, Birgitte.
Let's see. This is from your home directory. I can show you. Let's see. What you can do is that you could simply put what is it? The home core storage. So I will put that here as well. you could say here, like that. That will put it in your home directory. And username should be your, what you call this directory, which I suggest is your username. I'll just make this smaller so I can make it bigger, like this. Good. I will also copy this and put in the chat. And we could, we should first then go to the course storage. And then that. If you called it course storage, then you can copy, and then you can go to it and then copy this file, which contains all the hands-ons, to your directory here. And now I put this here. You see it's here. And you can see at this place I'm in, it also contains it. So this is the same place. Just will show the entire link if you go there by typing the entire path, or if you just use the soft link, it will show it to you as if it's a subdirectory of your home directory, but it is the same location.
Will they use the gun-zip command or?
This one was just zipped with the zip.
Okay.
I have a question.
Yes.
In the copy, should all of us copy from your like home/b/b Brydsö, because I get the permission denied.
That may be because I forgot to change the permissions. I will go and do that. Let's see.
Or can we copy it from your folder in the course folder right now?
Yes, you can.
Yeah.
And there you should have permissions. It's there as well. It's here. So yes, you can also just copy it from there.
Yeah, okay.
So just when you're in your own folder, then you would do copy this. Intro. Like that. I will just put this in the chat as well. So if we go into this directory here that it created, intro course master, then you can see there are some files here. There's a README file, there are slides, and there are hands-ons. And in the slides, you have, of course, the slides here that we are using today to give the presentations. And then if you go into the hands-ons.
You are not sharing your screen anymore.
What? How did that happen? Okay, just one moment. Okay, now I'm sharing my screen again, sorry. I will go back here. Okay, if you go into, when you do unzip on the file you just copied, you will get a directory called this inside your folder on the project storage. And it will contain these two directories and one file. The slides contains the presentations that we have just been giving, and then you should go into hands-ons with a CD to that, and then you can see there are 3 directories. One for the presentation earlier about HPC2N, and that was just a file that tells you to go and do and set up SSH client and try login. So what we're going to try here now is to go to 3.usage, which is where the exercises are for this session. And there will be 2 files to pay attention to. One is exercises and one is README. The .md is a markup language to make it look nice if you look at it on the browser. And it might be easier to have that beside you. Let's see, let me just take this. So if you go into hands-ons, usage, and then you can click on the README file will be there as the first one. And that one explains a bit about how you load and unload modules, and a bit about how to check on your jobs, and also what is contained in each of the examples and how you compile them and things like this. So that is some extra help for the exercises. If you go to the README file, I meant the exercises file. If you go to the exercises file, then you have the various exercises here. And it reminds you to go to README for help and hints. And the first one is the one exercise we have just done here, where you create a directory for yourself in this one. Then there is an exercise about loading modules, where you can try and load some of the modules and look at them a little bit. And I suggest to use the FOSS compiler, but you can also attempt to run with other ones. Just remember, then you need to make changes also to the batch script. You can also try and run some OpenMP program, and then try and see different outputs for it. So in this first, you just try loading modules. And then there's an example of how to submit a few of the batch jobs. And there are several batch jobs you could try and submit here. So I have all of them named as .sh for the batch scripts. And the rest is either C files or CUDA files. So try and submit some of the simple batch scripts. You will probably have to compile the various jobs. You will have to compile the C codes and CUDA codes first, but it's also that is explained in the README file. And there are some more exercises on the batch scripts to first try and change the tool chain. You can change the number of cores per task for the OpenMP job, and try and compile and run the different programs. And there's at the end, there's also an exercise on how to run the CUDA script. So I am going to try and go up and show how to run one of the simple ones. So I'm suggesting to use the toolchain 2019B of FOSS. So the first thing I'm going to do here is that I will load that. So now I loaded that toolchain, and if I type ml, I should probably show you how it looks before doing that. So this is the modules that are loaded per default. And now I'm loading the FUS 2019B toolchain. And then it looks like this. So it loads the core compilers. It loads some binary utilities and the various other small things that are needed for the compilers. It also loads hardware location thingy that you can use for some more advanced checking on where on which course you are running and other things like this. It loads OpenMPI, which is important. It loads OpenBLAS, path Fourier transformation, and scalar pack. And then it has the main name of the whole compiler toolchain. So as you can see, this loaded several other modules. And some modules will do that, some will not. You can try and play with it. I will also show you if you say ML Spider, then you get the long list of all the many various software that we have. And ML AV tells you what can be loaded from what you have currently loaded. So what if you knew that you wanted to load, for instance, GROMACS? Let's see, ML Spider GROMACS. Then it tells you that it has these different versions. So I will say, maybe I'm interested in this one. Then I say ML Spider and this version of it. And then it tells me that this is the module and these are the prerequisites that I need to load. It also gives a short description and a home page to the software in case. So I would say ML, and then I would load, for instance, these. If I wanted the CUDA aware version of GROMACS, or this if I just want the regular version. So I would take those. And then I would also need to load this one itself. And if I click enter now, I will load these modules. Okay. But right now we have loaded the FUS 2019B. So what do we have here in the directory? There is a number of C files, there's one CUDA file, and then there are some shell scripts or some batch scripts. And I would like to look at the simplest one first, which is the hello C.
So, Birgitte, one thing.
Yes.
Some people cannot copy the files. They mentioned that on the chat.
From this directory either, because that ought to work. That should not be necessary, but it might be. I will just check if it's somehow blocked. Let's see. Okay, you can now copy it. Because I'm standing in the wrong directory, like that. Okay, you should be able to copy all of it now. This one. So I would like to run this C file here. And in order to figure out what batch script I should use to run it, I can either, well, open them and look at them, or I can go in the README file and look at it there. And I'm going to look in the README file. You can use this slash here to search. And I'm looking for the hello.c file. And here I go here, and I am told that the serial example, in order to compile a serial program like hello.c, it suggests I do gcc hello.c -o hello. This is what I'm naming the executable. You do not need to put this part on it, but if you don't, then the file will be named a.out. And that means that when you compile another program, it will be overwritten. So you should name the executable. You can call it whatever you want to, but I have called it hello, and just to make it easy to see which one it belongs to. And it also tells you that the script corresponding to the serial example is simple.sh. Okay, so that means that I will now go and compile this small C code like this. And you can see it compiled it. And then I would like to look in the file simple.sh. And it looks like this. And there is nothing I need to change in order to run it. So I will just exit it. And then I will say sbatch simple.sh. And you can see here it submitted the batch job and it gave me the job ID. If I do sq -u and my username, I'm told it has already run. Let's look in my directory now, and you can see it created a file that is called slurm minus the name of this job ID .out. I will now look inside this file, and here I have this part, which is just some stuff it throws because it's just telling me, because I ran an ML purge and it's telling me it's not purging these. So this is something you can ignore. And then there's output, which is hello.world. If you have a different file you want to run, like the OMP hello, that is an OpenMP program. So if I wanted to compile that, I would do like this. I created a file OMP hello. We could just try run it here to see what happens, because it's a very small program. And it tells you the number of threads are 1. And you can do OMP num threads equals 4. And then you have 4 threads. And it runs that instead. So, and then let's try run it as a batch script. see where I have it. It's this one. And here it is setting the threads to the number of CPUs per task. And that environment variable here gets set to this number. And you can try and change it here and see for a different number of cores. Now I don't want to save it because I wrote some things that I shouldn't have. Okay, so I would suggest that people try and spend some time to try and run some of the various small scripts, make some small changes, compile stuff, load some modules and things. And I don't know how long we should use on that. I just want to look at the schedule. It was going to be only 13:45. I would suggest maybe take until 13:55. So let's work until 13:55 and see if things runs for people and works. So okay.